Hello everybody, we're getting ready to do lesson 11.2 of Algebra 1 Math, finding probabilities using permutations. And then here is our standard here. We got part 1, probability. So in this one we got a 10 points worth of notes to take, and we got a 36-point classwork sheet. And if you want to staple your classwork to the sheet, if you're online, make sure you take a picture of that attachment and send it in with your classwork. This is our bell work today, teachers. We got a table. During what kinds of game was Adam Vinatieri most likely to make attempted field goals? Justify your answer. And A, what was the probability that Vinatieri would make an attempted field goal, regardless of the point difference? So it's a table interpretation. Give your students 5 minutes. Okay, welcome back. Here is a possible solution here for it. Probability of him making a field goal with point difference of more than 15 is about 0.67, 2/3. And then probability of making a field goal is, here's our field goals made, field goals attempted, 25 out of 34. So regardless of the point difference is 25 out of 34. Okay, into our lesson 11.2, finding probabilities using permutations. You've used the counting principle. You will use the formula for the number of permutations, so you find number. A permutation is an arrangement of objects in which order is important. For instance, the 6 possible permutations of the letters A, B, and C are shown here. So here are the different permutations of it, different ordering of these 3 letters. Okay, in your own words, students, define permutation and n factorial. We haven't had that yet, so hang on to this. Hang on to this. This is 10 points here. It's not 0 points, so it's 10 points. Okay, so count permutations. Example 1. Consider the number of permutations of the letters in the word July. So in how many ways can you arrange all of the letters? So using the counting principle to find the number of permutations of the letters in July, we set up a situation verbal model. A number of permutations equal choices of first letter, so we have 4. And then times the choices for the second letter, which is 3, choices for third letter, which is 2, then choices for the last letter, which is 1. So here we go, 4, 3, 2, 1 equals what? 24. So 24 will be the number of choices that you could put July in, different permutations of the word July. So there are 24 ways you can arrange all letters in July. Example 1, count these permutations of the word July. This is B. How many ways can you arrange 2 of the letters? So when arranging 2 letters of the word July, you have 4 choices for the first letter, 3 choices for the second letter. So we have number of permutations. Choices for first letter would be 4, times choices for the second letter would be 3, and then choices are 12 for that. Choices for first, choices for second. So we have 4 times 3. So there are 12 ways you can arrange 2 of the letters in the word July. So then we go into our guided practice here. The independent practice, that's on you, students. So we have mouse, number of permutations here. Okay, choices, choices, choices. We have 5 letters. 5, 4, 3, 2, 1 will be our choices here for the word mouse. What's 5, 4, 3, 2, 1? It's 120 choices there. So there'd be 120 ways you could arrange the letter mouse. Okay, a factorial. Example 1. Now remember this for your vocabulary. You evaluated 4, 3, 2, 1. This expression can be written as 4 factorial, and it's read 4 factorial. For any positive integer n, the product of the integers from 1 to n is called n factorial. So the product of integers to 1 to n is written as n factorial. The value of 0 factorial is defined to be 1. So n factorial is n times n minus 1 times n minus 2, blah, blah, blah. And then 0 factorial would equal 1. In example 1, you also found the permutations of 4 objects taken 2 at a time. You can find a number of permutations using the below. So for example here, permutations, and we have formulas and examples. Number of permutations of n objects is given by npn equals n factorial. The number of permutations of 4 objects would be 4p4, so which would be this here. And then the number of permutations of n objects taken r at a time, where r is less than n, is given by npr, which equals n factorial over n minus r factorial. And then this would be an example here. Number of permutations of 4 objects taken 2 at a time would be 4p2, which is 4 factorial over 4 minus 2 factorial. And then these cancel out, and you have 4 times 3, which would equal 12. Okay, example 2, using the permutations formula. Your band's written 12 songs and plans to record 9 of them for a CD. And how many ways can you arrange the songs on the CD? Define the number of permutations of 9 songs chosen from 12. You go 12p9 for that. 12p9, and that would be 12 factorial over 12 minus 9 factorial. There's the permutations formula right here. And that would be 12 over 3 factorial. Subtract. That would equal 12, 11, blah, 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 down here to 4. And then our 3 factorials, they would cancel. So this would be your possible choices here for your song choices. Divide out, so we still have 79,830. What, 79 million? No, yeah, 79,833,600. Wow. Okay, so our guided practice here, what if, in example 2. Students, this is yours, and use your formulas here, your permutation. Okay, example, so which bands 15 songs, you will record 9 of them for a CD. How many ways can you arrange the songs on a CD? 15 choose 9, here's our formula. 15 factorial over 6 factorial. These cancel. Here's the number of permutations to be left with. That is some gigantic number there. And obviously when you're going to use your calculator, and then there are this many ways to arrange 9 songs out of 15. And that is 11.2, part 1. And if you need part 2, part 3, email me here. And if you need tutoring, etc., email me here. Thank you.